Welcome to this is Professor Ridge and today's lesson 8.2, the hyperbola. And our first learning objective, locate a hyperbola's vertices and foci. In analytic geometry, a hyperbola is a conic section formed by intersecting a right circular cone with a plane and an angle such that both halves of the cone are intersected. So remember what I said before, is if we drew that center line, we would say this plane is parallel to that center line. And that intersection creates two separate unbounded curves that are mirror images of each other. See figure 2. So in this figure, you can see this plane. If we slice it, and again, it would be perpendicular to that center line. So right, that will create, when you take the section, that will create a hyperbola. So you can see drawn here. So the intersection of the plane and the cone, right? Like the ellipse, the hyperbola can also be defined as a set of points on the coordinate plane. A hyperbola is the set of all points x and y in a plane such that the difference of the distances between x, y, and the foci is a positive constant. So here we're doing the difference. So for the ellipse, we did the sum of those distances was a constant. Here it's the difference. Okay? Basically, that's what I just said. So ellipse, it's the sum. Hyperbola, it's the difference. All right? So that's the key difference. And then if you do the difference, it creates the hyperbola. As with the ellipse, every hyperbola has two axes of symmetry. Okay, so for ellipse, we called it the major axis, minor axis. So in the hyperbola, it's going to be what we call the transverse axis. So the transverse axis kind of acts like the major axis, where it's going to be the vertices are on it, the center, and the focus 1, focus 2. Those are all on the transverse axis. And then the other axis, we call it the conjugate axis. Right? So the conjugate is perpendicular transverse axis, has co-vertices at its endpoints. Now these co-vertices, they're not on the hyperbola. The vertices are on the parabola, but the co-vertices aren't. Now, if you connect this let's see, let me finish reading this here. So the center hyperbola is the midpoint of both the transverse and the conjugate axis where they intersect. Every hyperbola also has two asymptotes that pass through its center. So we have the asymptotes. So remember, that's describing this end behavior as it goes out unbounded, right? So as it goes out towards infinity, this will get closer and closer to that line. So basically at all four of those. Okay. So we have these asymptotes, and we use those as aid to help us graph when we graph it. Let's see what else. A hyperbola recedes from the center. Its branches approach these asymptotes. As the hyperbola recedes from the center, its branches approach these asymptotes, right? So basically we're talking about that end behavior. The central rectangle, some books call this the fundamental rectangle. So if you just made a rectangle where the sides of the rectangle go through the vertices and co-vertices, then here this book's calling it the central rectangle. Is centered at the origin and the sides pass through each vertex and co-vertex. It's a useful tool for graphing the hyperbola and its asymptotes, because you can see right here, the asymptote goes through the center and the corner, the opposite corners, the diagonal corners, I would say, of that rectangle. So there's one asymptote. You just make this, I call it the fundamental rectangle. And then you put your ruler down and draw through the corners, the diagonal of that rectangle, and that gets you your asymptote. And then same thing over here, right? So you get two of them. So again, through the center and then the diagonal corners, you draw the asymptote. Okay, so basically, oh yeah, this says what I just said, right? So you're going to sketch the asymptotes through the diagonals of that rectangle. Okay, and then you can derive the equation of hyperbola centered at the origin. So we can do a similar like we did with the ellipse. We can use the definition of what a hyperbola is, the geometry definition, that the difference of these distances have to be a constant number. And then you can use the distance formula, set up the equation. And again, it'd be a good exercise for you to go to the textbook, read through each line and see if you understand what's going on. And you end up with, let me just copy the last line. You end up with, this is the standard equation for an ellipse centered at 0, 0. And then C, to get the C here, not the C for the constant distance, this C for the foci, you're going to add. So where C squared is A squared plus B squared. Okay, so again, I encourage you to read through the textbook. You know, look at how they derive it. It's not some magical thing that came out. It's just applying the definition, using the distance formula, and some algebra. Okay, so just like with the ellipse, the hyperbola has two different types. One that's vertical, one that's horizontal. So the first one, we're talking about the transverse. So this is a horizontal transverse axis. It's on the x-axis. Transverse axis on the x-axis. And then a vertical one, transverse axis on the y-axis. Okay, so basically a horizontal transverse axis, the way I think of it is the hyperbola opens in the x direction. And I always kind of think of if you put your pen on one of the vertex and draw an arrow to its corresponding focus, that's the way the curve opens, right? So it's opening to the right, and then this one is opening to the left. And then this one is opening up, and this one is opening down. Okay, so if it's a horizontal transverse axis, it's opening right, left, and if it's vertical, it's opening up, down. Now notice in an ellipse, we had the x squared over a squared plus y squared over b squared equals 1. But here for hyperbola, it's a minus. And notice there's no mention on which is bigger, a or b, because that doesn't matter. What matters is which is the positive term. So we got x squared minus y squared. And here we have y squared minus x squared. So basically I think of it as the positive term, right? The one so we got y squared and then we're subtracting x squared. So technically x squared is positive, but I'm just viewing this as if I think of this as a term, that's a negative term. That's a negative term, right? Because of the minus sign there. Okay, so if the positive term is x, that opens in the x direction. If the positive term is y, opens in the y direction. Okay, so that's kind of the way I look at it. And then now notice, so if it's the transverse axis is where your vertices and your foci and the center are on the transverse axis. Center's on both axes, but the vertices and the foci are on the horizontal or on the transverse axis. So if it's horizontal, you're going to add it, subtract it to the the x coordinate for both of these, and then the conjugate axis, you're going to do the b, right? So it's pretty similar to the ellipse with those minor changes. I'm going to erase this extra. All right, so let's try this out here. Oh, and notice the equation of we added something with hyperbolas. We have the equation of the asymptotes. So if you look at this, if you think of it this way, if it's going through the center, which is at the origin 0, 0, we know the equation of a line is y equals mx plus b. So since it's going through 0, 0, the y coordinate's going to be 0. I mean, the y intercept is 0, 0, so b will be 0. Okay? And then the slope, well, if you're at the center and you go plus a to that spot, and then plus b to this spot, then that slope is going to be, remember, rise over run, so it's going to be b over a. So that'll be your slope. And then that's this equation. Now if you want to go the other way, it would be b over negative a, so that would be negative b over a. So that would be the other asymptote. So getting the equation for the asymptote is pretty easy. All right, example 1, locating hyperbola's vertices and foci, or foci. Identify the vertices and the foci of the hyperbola with equation y squared over 49 minus x squared over 32 equals 1. All right, so let's look at the technique. Determine whether the transverse axis lies on the x or y axis. So again, it's going to be the one that's the positive one, not the bigger number. So we don't look at, so for ellipse, we look at the bottom, which was the bigger number. But for a hyperbola, if this is a minus, that makes it hyperbola, we look at which is the positive one. It's y squared minus x squared. So this is a vertical, y is positive, so that's the vertical transverse axis. So a is always under the positive term, so a is going to be, a squared is 49, so a is square root of 49, which is 7. And again, now when I do my vertices, since it's a vertical transverse axis, I'm going to add, subtract the a from the y coordinate. And since the center is 0, 0, our vertices are just going to be 0 plus or minus 7, right? You can write it like that, or you can write it as the two separate points. They are 7 and negative 7. 0, 7, 0, negative 7. And then the foci or foci or foci or foci, you can say it any of those ways. They're all accepted. So let's see. It will be 0 plus or minus c. So we got to figure out c. C squared is, now the way I remember it, it's for ellipse and hyperbola, you're going to do the opposite of whatever that sign is with the two numbers on the bottom. So for an ellipse, this is plus, so you subtract those two numbers. For a hyperbola, this is minus, which is this case. So you're going to add these two numbers. So it's a squared plus b squared, which in this case is 49 plus 32, which gets us 81. And then the square root of 81 is 9. So my foci, I should say it all 4 different ways, which I probably will. The way I learned it first when I was in high school, my high school teacher said foci, so that kind of stuck with me. And then, you know, when you're learning some Latin, you pronounce it foci, or even depending on the time period Latin, you can actually pronounce it a little bit differently, but we won't go there. Okay, so that'll be plus or minus 9. So again, we can write it as 2 separate points, or you can just write it this way, which is fine. Example 2, what is the standard form equation, standard form equation of the hyperbola that has vertices plus or minus 6, 0, and foci plus or minus 2 square root of 10, comma 0. Okay, so again, just like I did with the hyperbola, with the ellipse, I'm just going to make a rough sketch. Let's see, 6, 0. That was pretty bad. 6, 0. 6, 0. Negative 6, 0. You don't need to do this. Just for me personally, this is what I like to do it this way. And remember, it's a hyperbola, so if you do 2 square root of 10, shoot, what is that? It's like 6 point something, because 10 is, well, let's figure it out exactly. Just get a better idea. Not exactly, approximately. So 2 times 10 square root equals 6.3. Okay, so it's just a little pass. I don't have to do it exactly, actually, because I'm not graphing or anything. I'm just using this to figure out, is it vertical or horizontal? You can do it even without looking at the graph. So this is my A. This is my C. And it's a horizontal. So remember, it's going to open if you go from the vertex to the focus. That's the direction it's opening. So it's vertex to focus. So it's opening like that. That's going to be my hyperbola. So it's a side-to-side one. So the x squared is the positive one. So I'm going to use that form. X squared over a squared minus y squared over b squared equals 1. We established a is 36. 6 squared is 36. B, we don't know. We got to figure that out. Well, if C is 2 square root of 10, we're going to use this formula. B squared. Basically, that's just solving. If we do if we did C squared equals A squared minus B squared, or B squared minus A squared, doesn't matter. It's the bigger one minus the smaller one, right? You're going to take the absolute value of, okay, and then if you basically you can switch this, so it'll be C squared minus A squared. All right, so B, we don't know what B is. We're trying to figure that out. C squared is 2 square root of 10 squared minus A squared is 36. So 2 squared is 4. Square root of 10 squared is 10. So 4 times 10 is 40. Minus 36 is 4. So B squared is 4. And then again, I don't have to square root this because I'm going to square. I'm looking for B squared, not necessarily B. Okay, and then that's it. That's my equation in standard form. Okay, so standard form's equation of the hyperbola with center HK. So again, just like we did with the ellipse, we just make the appropriate changes with their transformation instead of being 0, 0. So notice again, you got x minus h, so you switch the sign, and y minus k, again, you switch the sign. And then make all the appropriate changes to everything down here, right? I'm not going to go through all that. We'll do it in the example. And then the same thing for a one that opens vertically. So notice it's x squared minus y squared is horizontal, and y squared minus x squared is vertical. Now, one of the big differences, if you have the asymptotes, right? If the center now is not 0, 0, it's HK, and you can use the point slope formula, which is y minus y1 equals mx minus x1. When you put in the HK, that's a point that's on both of the asymptotes. M is going to be, for this case, it'll be B over A. B over A. X minus X1, which would be H. And then you're just going to add K to the other side to put it in slope-intercept form. And then if you want, you can distribute that and simplify it, or you can leave it there that way. That's fine usually. Okay, so that's where this comes from. And then you got the positive one and the negative one. Example 3, finding the equation of a hyperbola centered at HK given its foci and vertices. So what is the standard form? Okay, we just read that. So here's the vertices. So again, I'm going to start out with just making a rough sketch. So let's see, 0, -2, 0, -2, and then 6, -2. Those are my vertices. And then the foci, -2, -2, and then 8, -2. So again, remember, so they're opening. So if you go from the vertex to the focus, that tells you the direction that portion of the parabola opens, or hyperbola, sorry. All right, so it's going side to side, so that's going to be a what do you call it? The transverse axis is parallel to the x-axis, so I just say a horizontal transverse axis. So x minus h squared over a squared minus y minus k over b squared equals 1. So the center is the midpoint between these two vertices or between the foci, either way. So the center is equal to, let's use the vertices. So vertices was 0, 2, so we're going to add the x coordinates, 0 plus 6 divided by 2. Add the y coordinates, -2 plus -2 divided by 2. So we get 6 divided by 2 is 3. -4 divided by 2 is -2. So this is at 3, -2. So now I can plug in x minus 3 squared. Okay, a we'll figure out in a minute. Y minus a minus 2. So y plus 2. Remember, you just change the sign. You can think of it that way. Oops. You got to figure out b equals 1. So now for A is the distance from the center to a vertex. So if this is at 3, -2, and then this one was 6, 2, 6, -2, so that must be 3 units. So A equals 3. So 3 squared is 9. And then B, well, we don't know B, but we know C. C is the distance from the center to the focus, to one of the foci. So C is going to be from, we're going from 3 to that one was what, 8, 2? 8, -2. So from 3 to 8, well, 3 minus 8, or 8 minus 3 is 5. So C is 5. So if C is 5, now we're going to come down here and use this equation. So let's see, b squared is equal to c squared, which is 25, minus a squared, which is 9. And then 25 minus 9 is 16. And then that's all you leave it. Right? We don't need to know that b is 4 and then 4 squared is 16. Right? You can always laugh when I'm grading tests. Everyone figures out b, and then you put in 4 squared, so you take like 2 or 3 extra steps. And it's like, we're just looking for b squared. Okay. All right, next learning objective, graph hyperbolas centered at the origin. Okay, so here's the technique in the book. I'll probably deviate from this a little bit, show you the way I do it. But anyway, let's read it once. So given the standard form, centered 0, 0, sketch the graph. Determine which of the standard form applies. So is it a vertical transverse axis or a horizontal transverse axis? So, and then you can determine the position for all those items, right? So you got to figure out which case it is, and then figure out all the coordinates of the vertices, covertices, the foci, and what are the asymptotes. And then what's this? Solve for the coordinates of foci by using this equation. All right. Plot the vertices. All right. So I do it totally different, basically. I do the graph, and then I can figure out all these things after it. And I'll show you how I do it right now. All right. So what I do first, make this a little bigger, is I start with, I just look like I'm doing an ellipse, and I'm going to do the 5 dots. So first I start with the center. So the center is 0, 0. And I plot these as I go. So 0, 0. Then I do like I did with the ellipse, under the y, square root of 8. So under y. And under, I do under x, under y. So under the y, that is 64, I take the square root of it, which is 8. So in the y direction, I'm going to go plus 8, minus 8 from the center. Under the x, I'm going to square root that number. So square root of 36 is 6. So in the x direction, I go plus 6, minus 6. Then I'm going to make, this book calls it a central, but I say fundamental rectangle. And if you remember, that goes through, oh, it's not dotted. Basically, you just need the corners of that. So the corners, because that's what's going to be for my asymptotes. So again, this is just an aid to help me graph. Okay, so if that was a plus, it would be an ellipse, and then I just make my oval. I would make my oval connecting this one, right? If it was an ellipse. If that was plus, it's minus, so it's hyperbolas. So then I make my rectangle, and then I'm going to draw my asymptotes through the diagonals of that fundamental rectangle. I guess I should write that in my step here. And draw asymptotes through diagonal of rectangle. Okay. Now, now I'm going to draw hyperbola. And note, if it's x squared minus y squared, then that's vertical. No, that's horizontal. And if it's y squared minus x squared, that's vertical. Okay, I just ignore everything else. So that's vertical. Okay, so this is y squared minus x squared, so it's vertical. So now I know this is my vertice. So this is vertex 1, vertex 2. This is my co-vertex, which is not going to be on the parabola, not going to be on it at all. So what I do is I go to vertex 1 and I just make a curve. We're just sketching, and I try to make a nice curve out to the what do you call it? The asymptotes. Okay, so, and then curve it down. And then I do it on the other one, vertex 2. And again, I'm going to curve out to the asymptotes. And don't be in a hurry to get there, but you want to make a nice curve. Oh, that was horrible. Let me try that again. All right. Okay, and then that's it. You're done. Except they want you to label everything. So vertex 1 is 0, 8. Vertex 2 is 0, negative 8. Co-vertices will be 6, 0, negative 6, 0. Foci, okay, we got to figure that one out. So that's c squared. You're going to add these. Oh, that was nice. Ooh, plus 36, which is 100. So c is square root of 100 is 10. So we go 10, negative 10. So it'll be 10, 0, negative 10, 0. And then my asymptotes. So this equation goes through the center. So this is y equals b over a. So that'd be, or a over b, I guess. Doesn't matter. So y over x, right? Slope. So it'll be 8 over 6, which reduces to 4/3 x. And then this one will be y equals, let me try that again. Y equals negative 4/3, negative 4/3 x. Okay, so that's my two asymptotes. I should write it over here. Okay. And that's everything. So that's the way I do it. All right, so I start with the center. Under the x, under x, 6, so I go plus 6 minus 6. Under the y, square root of 64 is 8, plus 8 minus 8. Then I make my fundamental rectangle, or the central rectangle, as this book calls it. Then if I'm doing this on a piece of paper, I get my ruler, put it through the corners of the diagonal of that rectangle, make my asymptote, make my other asymptote. And then I identify, is it opening left, right, or up, down. So remember, it's the positive one. It's y squared minus x squared, so that opens up, down. And then I just go to my vertice. That's the point that's on the fundamental rectangle there. And then I make my hyperbola curve, and I curve it out towards the asymptote and do the same on the bottom. Okay, and that's it. Okay, now next learning objective, graph hyperbolas not centered at the origin. All right, so our first thing to do on this one is we got to put it in standard form. So it's the same technique we did with the ellipses, where we put the x squared x term together, the y squared term, y term together. I'm going to add the 388 to the other side. Now I'm going to factor out the 9. I get x squared. Okay, what was it? Let's see. X squared minus, I got to divide by 9. So 36 divided by 9 is 4. And then complete the square. Now do the same with y. So now here I'm factoring out negative 4. So be careful. Negative 4 into negative 40. So negative 40 divided by negative 4 is positive 10. Add, subtract to complete the square. Okay, so now we're going to complete the square. So if you recall, you're going to take half the middle term. So -4 divided by 2 is 2. 2 squared is 4. So you add it, subtract it to balance the equation. These first three terms is the perfect square, x minus 2 squared times the 9. And then I got to take the -4 times the 9. Normally I'd just write minus 36, but just to show that step. Same thing for the y's. I'm going to take half that middle term, 5. 5 squared is 25. Add it, subtract it to balance the equation. These first three terms is the square. So -4 times the square. -4 times -25, which is 100, but I'll just write this down for now. Okay, so then I get 9x minus 2 squared minus 36, 4y plus 5 squared plus 100 equals 388. So add 36, subtract 100. So let's see here. If I do 388 minus 100 plus 36. I know I didn't do it in the right order, but it doesn't matter. Okay, now I'm going to divide both sides by the 324. Because I want 1. I want this to be 1. So I got to divide everything by 324. Let's see, 324 divided by 9 is 36. So we get x minus 2 squared over 36 minus 324 divided by 4 is 81. Y plus 5, 81 equals 1. Okay, now we're ready to graph. No, they want us to label everything again. Okay, so let me make my graph. Don't need that anymore. Let me pause. All right, so again, I don't worry too much about the way that they present it. I'm going to always start with the center, whether I'm doing an ellipse or a hyperbola. I start out and do the same 5 dots. Center, I do under the x, under the y. I make those 5 dots. If it's ellipse, then I make the oval connecting the outside 4 points. If it's hyperbola, then, I'm going to make the fundamental rectangle or the central rectangle, draw in my asymptotes, and then I can draw the hyperbola. Okay, so let's start. Center is, remember, switch the sign. So this would be 2, -5. So I go to 2, -5, which is right there. Actually, we can move this. So 2, -5. So 2, -5. And then under the x, remember that's plus or minus 6. In the x direction, so 2, 4, 6. 2, 4, 6. Under the y, square root of that is 9. So I'm going to go 2, 4, 6, 8, 9. And then down 9. So 1, 3, 5, 7, 9. Or, -5 plus -9 is -14. You think of it that way. Now again, if it was an ellipse, if that was a plus, I would connect these 4 outside with an oval. Okay, but it's not, it's a hyperbola, so I make my fundamental rectangle, or the central rectangle as this book refers to it. So you just need those corners. I don't actually have to draw in the rectangle. You can if you want. Okay, then I'm going to do my diagonals for my asymptotes. Then I got to decide, okay, is this a vertical or horizontal? So remember, you can ignore everything, but just look for, is it x squared minus y squared or y squared minus x squared? This is x squared minus y squared, so this is horizontal. Transverse axis. That's the way it opens side to side, right? So now I'm going to make my hyperbola. Basically, I probably need to go out a little further, but anyway, something like that. Try to make it smooth. I'm not really good at making it smooth on this tablet I have. I'm a little better in the classroom on a chalkboard. That's what I've been doing forever. But anyway, so forgive my poor artistic skills here. Okay, and then that's it, right? So, oh, but again, this question, they want you to label everything. So the vertex, so let's see, you can look at the graph now. That's what I do. 8, -5. And then this one is -4, -5. Oops. So those are the vertices. The covertices, so that would be 2, 4. This one would be 2, -14. And then the asymptotes. Now here's the trick for this one. It went through the center, which was 2, -5. So for the asymptotes, it's y minus y1, so y plus 5 equals the slope x minus x1, which is 2. Now the slope, remember, slope is change of y over change of x. So I don't memorize what they have in the, in the book, the a over b or b over a. I just look. So this is going up. How many did that go? This is change of y is 9 over 6. See, I look at this way, y over x. So 9 over 6, and that reduces to 3 over 2. 9 over 6, which equals 3 over 2. So the positive one is 3 over 2, and the negative one is negative 3 over 2. So this asymptote, and then remember, you're going to take this and move it to the other side. So it'll be -5. Okay? So it will be y equals 3/2 x minus 2 minus 5. And then this one is y equals -3/2 x minus 2 and then -5. Okay? And there you go. That's all the things they asked for. And our last learning objective, solve applied problems involving hyperbolas. Okay, solving applied problems involving hyperbolas. As we discussed at the beginning of the section, hyperbolas have real-world applications in many fields, such as astronomy, physics, engineering, architecture. The design efficiency of hyperbolic cooling towers is particularly interesting. Cooling towers are used to transfer waste heat to the atmosphere and are touted for their ability to generate power efficiently. Because of their hyperbolic form, these structures are able to withstand extreme winds while requiring less material than any other form of their size and strength. See Figure 10 for an example of a 500-foot tower can be made of a reinforced concrete shell only 6 or 8 inches wide. So very efficient design. Okay, the first hyperbolic towers were designed in 1914, were 35 meters high. Today, the tallest towers are in France, standing a remarkable 170 meters tall. Example 6 will use the design layout of a cooling tower to find a hyperbolic equation that models its size. Okay, example 6. So here's the cooling tower. tower stands 179.6 meters tall. The diameter is 72, diameter at the top. At their closest, the sides are 60 meters apart. So at the skinniest part, that's where the vertices are going to be. So find an equation of the hyperbola that models the size of the cooling tower. Assume that the center of the hyperbola, indicated by the intersection of the dashed perpendicular lines in the figure, is the origin of the coordinate plane. So we can put our origin right here. And let's see here. So basically, we know that we got these points here. So the distance from here, from the center to the side, is 30. So that's going to be A. So again, it's opening side to side, this parabola. So what happens is we're not seeing the whole parabola here. We have a little problem here too. See how this is vertical? So technically our equation is going to be off a little bit because we need to know what that distance is there. Oh, maybe we don't. No, we're not going to use that. So never mind. So basically like this. So we know, let's see, it's opening side to side, so it's x squared minus y squared. And A is 30, so that's x squared over 30 squared is 900. Y squared, find the equation of parabola, assume the center, round the final values to 4 decimal places. So B must be a decimal 4 places. All right, so how do we figure out B? So we need to know what C is. Let's see here. We have the height of this is 179.6. Oh, and they gave us this, 79.6. So from here to the ground is 100 meters. And this is 79.6. So this point right here is 79.6. So we're going to plug that into our equation to figure out what B is. So we have a point 79.6. And we're going to plug that in for x squared and y squared. Okay. So we get 30 squared over 900 minus y squared is 79.6 squared over b squared equals 1. So you see this is going to be 1. Okay, so this would be 1, and then 1 minus 1 is 0. Okay, I made a mistake somewhere. What did it? Oh, okay. So I kind of assumed this was 30, but it's not 30 because they gave us this figure here. So the distance from here to that point is 36. Okay, that's where I messed up. I was kind of like, wait a minute, 1 minus 1 is 0. We're not going to solve this. So 36 squared. Okay. So this is going to be a little bit less than 1, or a little bigger than 1. And then we're going to subtract. We want to solve for B. So let's see. 900. Well, let's just do this. Subtract the 36 squared. So 79.6 squared over b squared equals, I'm going to subtract that, 1 minus, what is 36 squared? Yeah, I'll worry about it later. Over 900. And then what I need to do is, let's see. All right, 36 times 36 is 1296. And then this is 900 minus 900 over 900, right? One's 900 over 900. So let's see, minus 900, but again, my answer will be negative. So this will be negative 396 over 900. I'm not going to worry about reducing it right now. And I got negative, let's see, 79.6 times 79.6. I should be using decimals because this GP calculator here. 6336.16 over b squared. Now the negatives, I can times both sides by -1, so those cancel. And then to solve this, I'm just going to cross multiply like that. So I get 36 that times 900. And then I'm actually going to bring the 36. So I'm going to get 6336.16 times 900 divided by 396. That'll equal b squared. Okay, which is 144,000.3636, so on, and then square root it. And they wanted me to go to 4 decimal places, so 120.0015. 120.0015. All right, but we wanted the equation of the hyperbola, so that's x squared over 900. Remember what I said, I was laughing at my students because they'll do this and then you got to square it when you put it in here. So I didn't actually have to do that. I kind of forgot what I was doing. So 14400.3636, and then the next number would be 3, so if I round it, it'd just be 36 equals 1. Hopefully that made sense. And sorry for the confusion about that original point. So let me go back and just restate it again. So when I first did it, I put in 30, comma, because I was thinking 30 and this was right above. But if I zoom in on that, you could see it's not. It's a parabola, right? It's going, I mean, a hyperbola. It's going away. So 30 is right about there, not there. And then they gave me this figure, and because of the axis of symmetry, here, this is 36, 36. Okay? So this point on the parabola is 36 for x, and then it's up. They told us 79.6. So that's where this point came from. And I plug it in for x and y, and then I just have to solve it for b squared to get my equation, because that's the only thing missing. And that brings us to the end of this section. So again, practice, practice, practice. Go to the end of the section. At the end of the section's exercises, do all the odds, and do more if you can. All right, and I'll see you next time. Have a great night.